In this video, we are going to talk about significant figures and the various rules that we need to use when we are counting them, using them for addition and subtraction, and using them for multiplication and division. A lot of the time, students don't really like significant figures because there are a lot of rules that you have to remember when you're actually trying to apply them to your science. However, it's really important to understand why we actually use them. So the reason why we use significant figures is because the measurement tools that we use as scientists aren't perfect. They have a certain amount of precision associated with them. For example, think about this ruler. This ruler can measure things as small as millimeters, but beyond that, if we try to go smaller, we're just not precise enough to do that. This ruler cannot make measurements on the nanometer scale or anything really smaller than millimeters. So the numbers that we use have to reflect that. There's no reason for us to measure that something is 5.3291 centimeters if we can really only measure the millimeters precisely. So let's talk about the rules for counting significant figures. The very first one is easy. All non-zero digits are significant. For example, in this number, 1,876, all 4 digits are significant because none of them are zero. It's when we start incorporating zeros that it becomes a little bit more complicated. Zeros are always significant if they fall in between 2 other significant digits. What that means is if we have a zero like in 403, that zero falls between a 4 and a 3, which are both significant. So the 0 is also a significant digit. That means that this number has 3 sig figs in it. Leading zeros are not significant, however. A leading zero is any zero that comes before the non-zero digits. You see this a lot with decimal numbers. A lot of the times we prefer to represent these numbers in scientific notation. But what you'll notice is that this only has 3 significant digits because those first 3, highlighted in red, do not count because they are leading zeros. So only the 9, 8, and 3 are actually significant. The next rule about zeros is that ending zeros are significant if they come after a decimal point. For example, these 2 zeros at the end of 475.00 are significant. We deliberately put them there instead of writing 475 with 0 decimal places. So this number has 5 significant figures because we are counting those 2 zeros at the end. The last rule about zeros is that ending zeros without a decimal point leaves us with an ambiguous number of sig figs. What this means is this could be 3 significant digits. All 3 could be significant, but we don't actually know that. The 2 zeros at the end might be significant or not. So it's not really advisable to write numbers like this if you can avoid it, because both of those zeros could potentially not matter. It could mean that one of the zeros doesn't matter, or they could all matter. If you want to imply that both zeros do matter, one of the things you can do is end the number with a decimal point. For example, we can write this as 200 with a period at the end. This will mean that all 3 digits are significant and we don't have to worry about there being any ambiguity in our counting of the significant figures. The final rule is that we don't count significant figures for exact numbers. So if you went into a parking lot and counted 22 cars, we would say that this has an infinite number of sig figs. Why? Because this is an exact number. We didn't measure the number of cars, we counted the number of cars. There's no way that you would have gone into a parking lot and counted 21.6 cars because they're entire objects. They're not something being measured. There's no ambiguity in how you counted them like there would be when using a ruler. Another example would be if you had 3 cats. You couldn't possibly have 2.5 cats or 3.2 cats. It's always going to be exactly 3. So now let's take some time to practice some examples. Here are several different numbers where you can count the number of significant figures. I recommend that you pause the video at this moment and try to count for yourselves for each of these numbers. How many significant figures are there? For the first one, there are 4 significant figures because we count all of the non-zero numbers and the ending 0 comes after a decimal point. In this number, we have 5 significant figures. Remember that all 4 of those leading zeros are insignificant. So all of the numbers after the zeros do count. We count the 4, 1, 0, 3, and the 2, making 5 significant figures. In this next one, we've written it in scientific notation. We don't worry about the 10 to the minus 3, we only worry about the actual numbers before the multiplication sign. So we count the 3 and the 4, giving us 2 significant figures. And in this last one, we have 8 significant figures. All of the digits are significant because the zeros will either fall in between 2 other significant numbers, or we have a 0 at the very end, which appears after the decimal place. Now let's talk about the rules for addition and subtraction. When numbers are added or subtracted, the way that we handle significant figures is that we round our result to the fewest number of decimal places in the original numbers. So let's look at what that means. For example, if we were adding 10.18 to 3.7, we would count the number of decimal places in each number. So the first number has 2 decimal places. The second number has 1 decimal place. So we cannot have our final answer be more precise than the least precise number in the equation. So that means that we need to round our final number to 1 decimal place to match the smallest number in the original quantities. So when we add them, we are going to round it to just 1 decimal place. Now let's talk about the rules for multiplication and division. We handle this differently than we would for addition and subtraction. So when numbers are multiplied or divided, we count the number of significant figures in all of the numbers, and then we round our result to the fewest number of sig figs in the original numbers. So let's take a look at what that means. In this example, we have 3,438 times 2.45. Let's count the number of sig figs in both numbers. We have 4 significant figures in the first, and we have 3 significant figures in the second. Again, we cannot have our final answer be more precise than our least precise number in the equation. So that means we're going to round our final answer to 3 significant figures, which will look like this. We get rid of the final digit at the end so that we only have 3 significant figures. And this is a slightly ambiguous way to write this number. Remember, we said that ending zeros that occur before we have any decimals will be ambiguous. So someone reading this number could also interpret this as 4 significant figures. One way that we can avoid this is by writing the number in scientific notation instead. This gets rid of that ending 0 that was ambiguous, and it lets the reader know that you have exactly 3 significant figures in your answer.